This tutorial video is specially made for my final year students who are doing introduction to Lebesgue theory and theory of integration, and who were given tests recently, but unfortunately they didn't do well in the test. I observed that they overread what they were supposed to study. So I'm bringing this video up so that they'll be able to understand and correct their mistakes. We want to look at some very simple questions that were given to them in the test, but which they didn't really get well. So this will lead us to kind of a review, a review on measure theory. Review on measure theory. So let's call it a review, Now, some funny questions were given to them, but unfortunately, they missed the question. So the very first question we shall consider here is, let A be a closed interval A, B. We're having endpoints A and B. Now, the question says, give one similarity between A and set of real numbers. Now, that's the very first question there. Then the second question, the B part of the question, what is the Borel algebra? What is the Borel algebra of A? While the last question under that one is give any two examples. Give any two examples of Borel sets of A. So these are the questions for number one. Now the solution to this question, very simple questions. A is given to be a closed interval. This closed interval is a set on its own. It's a set of, when it's a closed interval, it's a closed set because it contains all its limit points. So, being asked to give similarity between A and R, the simple answer is just that because A is a set of real numbers, both of them are sets. So, the answer there is both A and R are sets. That's all. It's as simple as that. Now, what is the Borel algebra of sets A? Beautiful. A Borel algebra is an algebra generated by all open, a subset of a set, or all closed subset of a set. Now, the set itself is what? The set itself is A is equal to A, B. So, the Borel algebra here, sets of, how many elements do we have in this set? 2. So, and the set is already a closed one. So, the Borel algebra is all sets, generated by open or closed. Definitely, the set that will generate is going to be closed one. If it is going to be the complement of it, it will be what? It will be open. So, this could be what? The set could be 1. A set of A, B, and 2 set of what? A, B here is closed. So, you can write it like this. Let's write it like this. Closed. It's a set. And the other one will be set of A, B, open one. That's all. That's what they are expected them to give to me there. Now, give any two examples of Borel set of, it's just like repetition. What are the elements that generate A and B? That generate all this? It's either what? A, B, the closed one, and open one. It's like repetition, except the difference that will be there in the use of curly bracket there. That's all. But they missed it. Quite unfortunate. Now, another question is, give the list of elements generalized by a measure. They have forgotten that a measure is a generalization of 3 main elements. A measure is an extension, an extension of the concept of one, length. So I wouldn't even like to write the question on that. I may write that question because of our time. It's a generalization on length. It's a generalization on area. And it's a generalization on the volume. They missed it. They missed it. The measure is just that this concept of measure enlarges, expands the scope of length, area, and volume. Now another one is because of our time, they are asked to express if chi e is a characteristic function of a set. Now express gamma as a step function of chi e. What a very simple question. Express gamma. This is obviously too simple. So just write gamma will be what? Summation of let's say a set of constants ci multiplied by the characteristic function of ei, where ei is what? Sigma algebra generated by set x. Suppose x is the main set there, and all ei's are sigma algebra that are generated from set x. So if x is coming from that domain, I'll put gamma of x and all of these of x. That's all. Now a very simple question is asked there, that give another name for a characteristic function, an indicator function. Another name for characteristic function, this is called indicator function. I believe you know how to define this. How to define chi ei is going to be 1 if x is in ei. It's going to be 0 if x is not there. It's as simple as that. If x is not in ei, it's not in that subset. And don't forget, ei is what? The subset of x, because the set of it's a collection of subsets of set x. So other interesting questions they were asked is to state the set theoretic axiom that is equivalent to the concept of almost everywhere. That is what? Complementation, set complementation. Set complementation. Now, another very simple question I asked them, which most of them didn't really understand, is the concept of do you agree with the statement? Every step function is a simple function. Use the concept of set and its subset to corroborate your assertion. Every step function is obviously a simple function. A set function has the domain of set of intervals, while the a simple function has a step function has its domain to be set of intervals, while simple function has its domain to be measurable sets. And so we can get measurable sets, we can get a set of intervals from measurable sets. Not only that, a step function is used majorly in Riemann integration, while simple functions is used in Lebesgue integration. And Lebesgue integration is an extension of Riemann integration. So with that reason alone, every step function is a simple function. And apart from that, a step function is a subset of simple function. So a step function is a subset where simple function is a set. So these are questions, these are very funny questions I asked them. Although some of them got it, while few, did not really understand the concept very well. So I decided to bring up this video so that they will be able to correct themselves in case of future needs. So with this, we have come to the end of this short review on measure theory. Stay blessed.